Okay, ladies and gentlemen, thank you very much for joining us this afternoon. It's great to see so many faces of you here today. A couple of years ago, when we had the Aerostructures breakout session, we were in a room no bigger than a classroom with around 20 or so people in there. So it's great to see we've got a bit of a bigger space and one or two more faces there today. So this afternoon, some of you might have been here for the vehicles breakout session. We're going to focus today on the Aerostructures strategy and a bit more speaking to some of the leaders in the aerostructures world within aerospace. So we're going to start off with an introduction from Alex Hickson, talking about the aerostructure strategy from the ATI's perspective, drilling down into some of the key priority areas. Then we're going to speak to Paul Pereira, GKN, Brett Hemingway from BAE Systems, and Martin Bolton from Airbus. So if you've been in the previous breakout sessions, you would have seen that we're using Slido to collect some questions. So the code is 4167. So please, if you think of any questions throughout the session, do join that Slido session, ask your questions, and we'll be asking them to our panelists later on. So without further ado, I'll pass on to Alex Hickson. Alex Hickson joined the ATI in April of this year. And myself and Alex have been working with a lot of people actually in this room to define the aerostructure strategy, and Alex is going to give you a bit more of an introduction into that.
Thank you very much. So good morning all. My name is Alex Hickson. I'm the Head of Structures, Manufacturing Materials at the Aerospace Technology Institute. So today we've heard a lot of the challenges of the aviation industry. And they've been very clearly presented in the sessions this morning. Reducing the environmental impact and terms such as becoming carbon neutral clearly are important, but whilst maintaining the competitive nature of the industry and addressing future mobility needs is clearly a significant challenge going forwards. The ambition is there. And clearly there's a great body of work that is already going on in the UK, much of it funded by the ATI, and a lot more that's in development. But there's more that we clearly need to be doing going forwards. Part of that is to start addressing some of the major challenges to achieve those ambitions of sustainability, competitiveness and mobility. We need to reduce the buy-to-fly ratio that was mentioned in the earlier session significantly. So that's about reducing the material that we use in the manufacture of individual components and assemblies. So being more efficient with the resource and material. The targets on that are pretty significant. So in the timelines we're talking about 20% by 2025, 35% by 2030. And 50% by 2035 are pretty huge. These are felt to be potentially attainable. It obviously depends on what baseline you're talking about, but they require some significant changes in the architecture, materials, manufacturing methods, even the design and test methods to achieve these. And a lot of technology is required to deliver against these. We also, in terms of remaining competitive, and also at the projected increased rates associated with large commercial aircraft and potentially the expanding small electrification and hybrid market, need to be looking at increasing productivity. And again, big targets there associated with that timeline. Some of the programs we're working on are working towards delivering against these, and it's about reducing complexity in some of the assemblies. But that takes significant investment to achieve. The other key part in achieving the efficiency of aircraft in terms of fuel burn, in terms of meeting the environmental targets, is about airframe weight. And again, some pretty significant numbers on that. So we've seen since the introduction of the A320 single-aisle aircraft, obviously a massive increase in the use of composites, going up to over 50% on the A350. These numbers may well go up further and will be achieved also through further integration of components and assemblies. and further optimization of structures and the analysis techniques to enable them. But we still need to deliver all this whilst delivering on the current safety standards, but improving on them, particularly where new challenges of autonomy and new materials and manufacturing methods are being used. All this, to remain competitive, requires us delivering these components at reduced cost. And that's about not just reducing the complexity of the systems, but looking at the manufacturing methods associated with them, the lead time in manufacturing, the non-recurring costs associated with the equipment. We need to be conscious of the amount of energy we're using, not just in the transport of the aircraft, but actually in the manufacturing methods, techniques, reducing the energy consumption in each component that's made. We need to make sure that we're recognising the requirements of protecting the environment. That's looking at the methods and processes we're using, obviously breach compliance. So as new materials coming along, we're being compliant with those. The operational needs and flexibility, this is quite key as more variants of aircraft come along, that the manufacturing systems are able to adapt and change to those needs. At the moment, we've got very much embedded manufacturing systems that have challenges when those changes are occurring. And all this whilst delivering on improving the passenger experience, so working on reducing cabin pressures, etc. So some of the key priorities to deliver on these. The future integrated airframe is key to ensure that we have more optimised integrated structures. Multifunctional structures, looking at the overall efficiency of the aircraft, looking at such things as morphing structures, but also how those carry sensing and power to, again, reduce the amount of systems that are bolted on that are part of the overall manufacture of the aircraft for reduced weight, but also optimisation aircraft during operation. Flexible and automated large-scale assembly is a major challenge for the next generation of aircraft. We're talking very large structures and moving away from lots of individual components into larger single-piece components. That's requiring significant challenges and the complexity of the tooling and assembly systems to manufacture them. These are capabilities that we have in the UK but need to grow and develop to ensure we're securing future wing work. So advancing those key capabilities for future integration, one of the key methods of achieving the reduced bias-flight ratio is improving on near-net shape manufacturing processes. This is something that I was presenting on at the AGP launch event around 5 years ago, when Airbus was pushing a similar message around the need for doing this. And we've seen since then significant investment in additive manufacturing, but also a number of other advanced joining technologies. So solid state joining being one key, another one for metallics, castings technologies, but also obviously the optimization of near net shape composite manufactured components as well. Fully unitized, topology optimized components is quite key for ensuring material is where it needs to be, and the digital analysis tools are also helping in delivering on that. And putting material where it's needed in terms of multi-material and functionally graded materials. The optimization of composites is quite key. We're saying the percentage utilization of composites is potentially going up in future aircraft. Part of that is about how you create future structures, more complex potential structures, whilst composite materials are inherently expensive. How can you reduce the cost of those through the manufacturing processes? So in some areas moving away from pre-preg technologies to other manufacturing methods. the ability to make even more complex components to meet more efficient integrated designs, looking also at the energy associated with the manufacture, the curing of those composites, and also addressing one of the key other aspects is the recycling of those materials, reuse of those materials. Structural damage tolerance is also key from a point of view of reducing the level of maintenance and repair associated with the manufacture of products, and the efficiency of the aircraft through understanding what's happening through automated structural health monitoring. Design and test is also a key capability that we need to invest in the UK. As part of, as described earlier, the high value design is key to determining the manufacturing methods and helping secure that work. Part of that is about reducing the lead time on the manufacture of next generation aircraft. So from the typical design life cycle of 10 years, compressing that potentially to 6 or even 5 years. And the key skills that we'll need to develop that and ensure we start not just in improving the design, but moving to virtual testing, reducing the testing costs and time frame. Growing the capability in multifunctional structures means more integrated structures, the integration of systems into those structures. Looking at structural power, so if there are batteries in systems, how do we use that? Because that weight is part of the overall weight of the aircraft. So making a lightweight vehicle through a more integrated design, and having multifunctional primary structure that's serving more than one purpose. So how do you integrate systems into that? Morphing structures is quite key, particularly when we look at more electric aircraft and the distribution of power across the structures. And part of delivering the target on more efficient aircraft is about how we enable laminar flow. So use of the structure to enable hybrid and natural laminar flow, more accurate joining methods for reducing the tripping of the boundary layer, but also looking at how do you get the structure in higher aspect ratio wing structures. So ensuring that we're developing the capability for design and production of those complex structures is key to the UK going forwards. Smart assembly processes will mean that we will be able to manufacture structures more efficiently. Part of that is about eliminating fasteners through whether it be more integrated composite components or fastenless metallic structures. And that's not just in at the components level, that's all up in the assembly of the structure, because the amount of time associated with putting material into the structure and then taking it out and the actually required is significantly costly and not conducive to high rate manufacture. Smart tools and techniques will be important for the manufacturing of those components in terms of transformable smart assembly and tools, automated assembly systems, and the reconfigurable nature of those factory systems to ensure the systems can adapt to different platforms and different requirements. Bringing this all together needs to be done in connected factories, and that's manufacturing processes connected within factories, but also the connection of the supply chain for the flow of data from the different manufactured components into overall systems so that the overall manufacturing process can adapt to the variation of variability throughout the supply chain to enable more efficient manufacturing. The UK needs to invest in these technologies to transform the aerostructure assembly from manually intensive processes they typically are today to more highly automated, digitized, self-optimized operation. So from these technologies, the ATI has put together an aerostructures roadmap which brings together the key drivers of aerostructures, the market, the targets set to deliver those, put against a time frame and the technologies that will enable those targets to be met. The key is there's a lot of ambition. There are some demanding challenges. In order to deliver these, we will need significant collaboration within the industry, but also across sectors and across academia, catapults, industry and government to ensure the appropriate investment and innovation, and addressing what was mentioned earlier about having these skills as well as the capabilities in the UK to deliver on these targets and secure the work for manufacture, and having the design capability within the UK. So, thank you very much.
Yeah, thank you, Alex. I'm going to introduce Paul Pereira from GKN. Paul Pereira is a Vice President of Technology and Innovation. Has had extensive work in additive manufacturing, composites and metallics, and has also been very involved in the ATI accelerator, which has been taking place over the last few months, and something that you'll hear a bit more about tomorrow. Maybe Paul mentioned it a little bit in his presentation just now. So if that's worked, I'll hand over to Paul.
I hope it's worked. Just checking that's coming up. So, well, thank you for the introduction, Noor, and Alex, I think you've set the scene beautifully for what I wanted to try and cover in a very short 5 minutes. I've slimmed down my presentation to allow more conversation. But I think I'm on message with the ATI strategy with three things: sustainable aviation, accelerating innovation, and that's just triggered me to talk about that a little bit more, and the application of Industry 4 in structures that are disruptive. I just wanted to give you a quick overview of why I'm really excited to be here today by just showing you a quick video. Listen on. There is some volume, but well, I'll talk over the top if we can't. For a company that I've joined just over 2 years ago, what's really exciting to me is we've got the combination of a power systems business, a systems business, and of course an aerostructures business. There aren't many in the world that can integrate those three things in one organisation. So when we look to the future, the way we see things is through the lens of a whole systems integration capability, of which a structure just happens to be the load-carrying part of the system. And what we do is forge really strong partnerships in all areas and domains that we cover, whether it be through the power and propulsion piece. We're looking at batteries, fuel cells, and we're looking to integrate those into structures, whether that be through our systems, which we work on, electrical systems within many, many aircraft. We do the whole electrical wiring and harnessing systems and design, development and production. We work across into systems like heater mats for the 787 on the Boeing platform to try and take out the amount of energy used by ice protection. We use our people and leverage the strengths of those. And one of the challenges that we've got going forward is to make sure that we do this in a collaborative way. So what I'm going to share with you is three things. Why we believe it's really important to tackle the challenges in a radical way around structures. When we look at the aviation growth, you've probably seen these slides buried in a few slides that Paul Stein's produced, and I think there's probably one there from Simon as well. But that thing there, that target of 50% by 2050, if we remain doing technology as we know it today, will not take us to the point where we're even carbon neutral. And our target is 50% under today's carbon outputs. And that is everything wheel, so from well to wheel, as we call it, from the drop of oil that we take out of the ground to the point we take off, we have to take 50% out of our manufacturing CO2 footprint. I think Dave captured that in the last session. It's not just about how we deliver lightweight, optimized, topology optimized additive structures in the future. That radical thinking needs to go even further into the whole production process. So when we're looking at structures for the future, we need to be thinking about completely different designs. Otherwise, these economic factors like carbon taxation, aviation fuel will hit us, and we won't be able to do much about it. And I think the UK opportunity, and this goes for everyone in the UK in this room, is actually one of co-creation of new technologies. Because much of what we see going on is not science fiction, it's science fact. Many of the technologies that we actually have in our fingertips today are available to solve some of the challenges that we see. It's about integrating them together. I think advancing them, getting the regulation under control, making sure we've got proof cases and the data that supports it. But actually, if we work together, I think this vision isn't that far away. And I know Michael and the team share the vision of flying these vehicles and potentially larger vehicles within 5 years. I think it could come even sooner elsewhere in the world. And then the challenge is, how do we bring that together with the technologies that we're working on in GKN and others? Well, we've been working on the industry we're kind of deeming it GKN 4.0 until we get an industry standard. But some of the things we're looking at are different ways of working, so we can augment workers with data to take out additional efforts in terms of our structures. We've actually got people working in a lights-out factory for Wing of Tomorrow right now, so there may not be that many workers. The digital twins, we're looking at validating simulation, working with Bath University and a number of others, where we can take out a large part of the testing pyramid, virtual testing. We're doing a lot of work, as everyone knows, in additive manufacturing with a huge program of effort over the next 5 years. And we're doing that under the auspices of a Made Smarter program. What does it really mean? I'm really speeding up. We think that co-creation is the answer to solving some of the challenges that we have. We're building a global technology centre in the UK, thanks to ATI and Innovate and the UK government. That is looking at, focused on technologies around additive, thermosets, but as we move forward, we're going to integrate that across Sweden, the US, and the Netherlands to build out a complementary capability set. It's all about failing fast, and we talked a little bit about it now. We are working with startup companies. We advertised with Boeing in a partnership with the ATI that we would encourage startups into this centre. We ended up 5 weeks ago releasing the opportunity to work with us and Boeing to do proof of concepts over the next 6 months. We, within 5 weeks, have got 220 companies, many of which are structures related, and looking at things like additive, digital twins, blockchain, building out solutions. It's really exciting to us that the problems that we're trying to solve can be solved by people already. So I'm not going to dwell too much longer, apart from to say we're trying to fly future technologies today, and some of the team in the room here are working on a program which is called our CTO vehicle, that I actually created by Chris Gear, who's last few days as the ATI board member for GKN, but the team has been working hard to realise this vision. That isn't just a figment of our imagination, that's going to fly with our colleagues in Thalys's West Wales Airport in January, and we're going to fly that vehicle to demonstrate some of the future technologies we want to demonstrate on a larger single aisle, including things like sustainable aviation using things like hydrogen. We believe that the future has to transition in terms of capability. When you start loading structure with big cryogenic fuel tanks with liquid in them, we need to find volume, because volume is key, and we're going to be putting that into the vehicles. So we're going to be working out how to take out additional weight batteries and replace them with volumes of hydrogen. We're going to be working on things like boundary layer ingestion, which will require completely different structures. We already have worked on laminar flow. We're working on structural batteries within this program, and in the future, we're looking at morphing structure. So those are just some of the areas that GKN is interested in and happy to collaborate on. But that's it from GKN. If you want more details about what to scan that, and you can get a full copy of our detailed presentation.
Thank you very much, Paul. Really interesting, really exciting to see that CTO platform fly at some point in the future. Just a reminder all, if you've got any questions to ask any of our panellists, you can ask them through our Slido app. We've got some really good questions there so far, something for you all to look forward to at the end of the session. So I'm going to introduce next Brett Hemingway from BAE Systems. Brett Hemingway is a principal technologist in the manufacturing materials strategy and technology team. Brett's worked on the F-35, Typhoon, Tempest, Solar Hill, and is also an active member of the Composite Leadership Board. So, hand over to Brett.
Okay, good afternoon. I'm going to give you a little bit of a perspective on what some of the military aerospace drivers are, with a sort of bent to dual-use technologies. We're embarking on a project at the moment called Tempest, which is the technology demonstrator program, which will hopefully lead into the acquisition program for 6th generation fighter, looking to replace Typhoon circa 2030. So these are some of the some of the technologies that we're interested in. The strap line for Tempest is half the time, half the cost. So obviously we need to respect that. But we've still got the usual drivers. We've still got the mass targets. We've still got the performance targets. And ever increasingly importantly is the ownership cost, the maintainability costs. As one of our in-service support directors pointed out to me a few weeks ago, we're 10 years in the making, but we're 40 years in the supporting. So what we're doing on R&D as far as support activities is concerned. We've got, we're looking now ever more at multifunctionality and whether structures can do a secondary role rather than just the structures. A couple of people, both Alex and Paul, have touched on the fact that power generation storage. Batteries are parasitic, they're parasitic mass, but more importantly for us as well, it's freeing up real estate. We've got ever more complex sensor suites and what have you, and we need to free up that real estate to actually allow us to put more of those sensors in. So we can put the power in the structure, then that helps us with that. Similarly, communications as well, the use of surface wave technology. We did a study on the avionics bay of Typhoon 12 months ago, and we found out that connectors alone for communications purposes, there's 22 kilos of connectors in a typical fighter aircraft avionics bay. So again, that's an opportunity to actually get the mass out of there. Air elastic tailoring as well. So rather than just looking at manufacturing technologies per se, what can manufacturing technologies do for us as far as getting mass out of the structure is concerned? And if we look at direct mass saving, we've done a study with Bristol University looking at if we can alter the direction of the fibre to suit the direction in load, we can get between 12 and 25% mass saving, depending on how radical you actually want to go on that. And on indirect mass saving, that same fibre steering allows us to do air elastic tailoring as well. And if we can get a 6-degree twist in the wing of Typhoon, we can get about a 2-ton fuel saving. And I'll go into that a little bit further later. Some of the issues that we've got with integrated structures, and certainly looking at smart structures, is some of the thermal management technologies that we need to look at in future. If we're going to start embedding sensors into the structure, EO windows, antenna, that sort of thing, then how do we cool them? And that's looking at how additive manufacturing can help us with the heat exchanger technology, the use of nano additives in the fluid, and also acoustic damping, certainly on military aircraft. When we've got the weapons bay door open, we're talking of acoustic levels of about 165 decibels, which in itself is not conducive to flying. So we do have issues on that one as well. So if we go into them a little bit further, structural power, battery replacement, what do we want from that? Well, there is work going on at the moment within ICL, SimComp, EPSRC, places like that, but we do need an increased energy density. They are relatively low. They will power single systems, but also getting them more structural as well. You know, the terminology structural power at the moment is a bit tenuous, and we need to look at how we actually increase the structural performance as well as the energy density on those. Energy scavenging. In order to get the maintainability cost down, we believe that the use of wide area structural health monitoring, integrated structural health monitoring is a way to doing that. So having an array of sensors over the wing skin, for example, means that you don't have to have periodic maintenance, you have condition-based maintenance, but then we have how do you power those sensors, how do you actually interrogate the sensors, etc., etc. So again, that's all power related. And then we've got lightweighting, copper wire replacement. As I said before, 22 kilos of connectors, we couldn't actually work out from a comms perspective how much wire was in there, but it's a significant amount. So can we start looking at things like spun CNTs, that sort of thing, the stuff that our guys at Cranfield are working on. Wireless communications, again, internal comms. We've been working on black boxes on avionics bay shelves. talking to each other over surface wave technology. We'd like to take that into external comms, but then we've got things like how do you use cyber security. If the pilot can actually tell the actuator to actually move, how do you stop somebody on the ground actually interrupting that? As I said before, one of the biggest things that we believe on future military aircraft wings is going to be the biggest differentiator is the ability to tow steer. As I said before, if we go for challenging ply layup convention, so traditionally we've always gone with plus minus 0.90. Over the past 40 years I've been involved in composites, you get a certain mass. If you can change that to 10 degrees, 12 degrees, whatever the most efficient way of doing that is, you'll get 12%. If you can actually steer the tow to change direction, you can actually get that mass saving down to 25%. And more importantly, as I said before, that 6-degree twist in a Typhoon wing means that in order to pull 8G manoeuvres at high altitude, you no longer need afterburners. And 2 tons of a 10-ton fuel load is for afterburner use. So in theory, that manufacturing process can actually save you a significant amount of weight, and I'm sure the same for civil aircraft. Heat exchanger technology, as I said before, additive manufacture, it gives you a new design capability in that you can put things into the structure that you couldn't put in there before. And the use of nano additives into the cooling fluid can increase the thermal conductivity by an order of magnitude. The acoustic damping one, I'm sure there's something that we can learn from the propulsion guys on that one. As I said, 165 dB, we need the need for palliatives. Also looking at damping materials, active damping, that sort of thing. So there's a lot of things within the military aircraft field that do also we can learn from the civil aircraft guys, and conversely vice versa. So again, I'm looking for collaboration opportunities in those areas. So if you do have any, come and see me afterwards. Thank you.
Thank you very much. You mentioned at the beginning of your slides trying to achieve half the time, half the cost. I think a lot of the companies in the room will be interested to see if you accomplish that in the future. It's a big challenge to try and achieve. So last but not least, I'd like to introduce Martin Bolton from Airbus. Martin is the head of assembly for Wing of Tomorrow. Previously, he's had experience in the A330 as well. You'd have heard from Simon Weeks this morning that the AMRC North Wales are opening their facility in a couple of weeks, which is actually on the Airbus Bolton site. So I think, Martin, you'll be moving into there shortly. And Martin's got the difficult challenge in the next couple of years or so, or assembling the next 3 Wing of Tomorrow boxes.
Thank you.
Hand over to Martin.
Thank you. Lovely. Okay. So as has been mentioned, so I'm responsible for the Wing of Tomorrow assembly based in Broughton, a new AMRC facility that's been built with their government support. And me and my team will be responsible for the building of the assembly system, which I'm going to talk to you a little bit of one of the elements today in terms of adaptable manufacture and robotic assembly. But we'll also be responsible for the operational production build of the 3 demonstrators. So I've got a couple of slides today, one on just the general context of why we're doing what we're doing, and then one finally talking about Wing of Tomorrow assembly. Success? Yes. Lovely. Okay, so why are we doing what we're doing today? So today, just for a bit of context, within Broughton we manufacture all of the commercial wing sets for Airbus at roughly about a rate of 2 per day. So just to give a scale of the manufacturing and assembly rate that we're talking about. And we do that from an assembly perspective in, as Alex has mentioned, relatively bespoke, highly complex, monument-based tools. And what I mean by that is if you just look at some of the pictures that are on this slide here, what you'll see is significant superstructures that support end effectors, be they clamp, drill, or fastening machines, at a single point of use. So if you can see from the scale on the bottom left-hand corner, that is actually a bit of a representation from an A350 machine, and those heads tend to be up to 4 to 5 feet wide. They tend to be hundreds of kilos in weight, highly complex, highly bespoke to the particular activity that they're partaking in or they're doing. The benefit of these machines is that they are very accurate. They are very high quality, and they're very repeatable. But they're predominantly designed in this manner because of the way in which the product has been designed to support performance more than industrialization and assembly. So what we're doing from a Wing of Tomorrow perspective is, and I like to say this because I'm assembly, is Wing of Tomorrow is mostly an industrialization project. So it's how do we design a product that is designed for industrialization and is designed for automated assembly. And that's what I'm just going to spend a couple of minutes talking you through today. So within Wing of Tomorrow, we will be building 3 demonstrators in the MRC facility. You can see we've literally just moved into the facility in the last couple of days, and that's the production area that you can see on that bottom left-hand corner. And we'll be looking to install automated assembly equipment in a clean floor manner. And what that means is that it is robotic systems that you can see in the corner on the right-hand side, mounted on top of automated guided vehicles that enable us to deploy that technology flexibly in the cell that it's required, either operationally or through quality issues. And we can start to use multiple systems in the same cell. If you saw the pictures beforehand, each of those machines in our current facility work in a particular cell and can't be transferred due to quality or production issues. The idea of Wing of Tomorrow that we're looking to demonstrate is how do we build a very flexible assembly system and use those mobile robotic platforms in order to do that. The challenges of that are that those systems have to be fast to set up, they have to understand where they are in the facility, be able to be datumed and drill to a similar accuracy as our current products. So that presents us with some significant challenges. What it also means is the integration of these systems together will drive most of the challenge or difficulty in the next couple of years in terms of how do we make these systems work side by side in a cohesive and safe manner. And that probably brings me to my final point, which is a lot of these systems will work in a safe environment with people. So we're working quite clearly with some government regulatory and health and safety executives to say how do we start to prepare the UK health and safety environment to use these types of equipment in future factories for our next products. Okay, thank you very much. I look forward to your questions.
Thank you, Martin. Thank you very much, and thanks to all of our speakers. It's really interesting to see the different perspectives coming from all 3 of your companies there. So I'm going to go straight into the questions here from Slido. Reminder, if you've got any questions, we've got a little bit of time before our next break, so we're going to go through them. Just ask them. The code is 4167 if you go to slido.com. So the first question has got quite a few votes. It's what innovation in composites would you like to see that would make production easier?
Can I start?
Yeah, please.
Well, firstly, I think great question. We think about how we can make efficiencies out of composites all the time, but the thing we really worry about most is the flexibility and agility of composite systems. The tooling element takes a lot of our time in design and development and is a large expense. But if we want to be flexible, agile, meet some of the challenges of both Airbus and BAE and Rolls-Royce for that matter, in the future we need to be able to shift the tooling lead time down a lot. So we're looking at additively manufactured tooling as one option to do that, but we're also looking at ways in which we can print composites as well to give us that agility and speed. I think those are the 2 challenges that we see in the longer term. Nearer term, I think the challenges are around how do we bring the multiple assemblies together and try and integrate them more quickly and cleverly, and I think we're talking about similar things as Airbus is at the moment. But those are the 3 areas that we'd be concentrating on.
Okay. Martin, in your presentation you mentioned design for automation. I guess similar themes around that as well?
Yeah, so some of the themes there aren't specifically related to composites because clearly a lot of that is driven out of the tolerances and design processes that go into composites manufacture. But quite clearly, you have to build and design structures with an industrial understanding at the same time. And that's exactly what we're doing from a Wing of Tomorrow perspective in a demonstrator environment to show the benefits of when you do that activity.
Brett, Alex, anything else to add to that?
I think for us, similar to what Paul said there, I think the reduction in NRCs are a big issue, especially at our build rates. I mean, we're on the F-35 program, the biggest sort of military program ever, and we're still on with build rates of 160 a year at peak rates. So we don't have the opportunity to amortise over the same number of units as the civil guys do. So again, large-scale additive manufactured tooling is an area. But I think some of the other areas, again, is more integrated composite structures, let's get bonded assemblies over the line. I mean, we've been flying bonded assemblies on demonstrator aircraft and indeed on Typhoon for some considerable time, but trying to get those bonded structures into mainstream primary structure is a big issue. Alternatives, tufting, but fastenerless assembly basically. So how do we get integrated composite structures and take advantage of the sort of 3D composites as well at the same time? So,
brilliant. I'll move on to the next question. I'll start off with Alex. I know this is one that's close to your heart. How can we improve recycling of our materials at build and assembly stage?
It's a good question. Partly obviously it depends on the materials and process that are selected during the design stage, so consideration for end of life is clearly important, as well as having the technologies and infrastructure to recycle those materials. Obviously it's an awful lot of recycling happens with aluminium today, but an awful lot of work is going on around recycling other materials. So part of that is having the research that's going on within academia and within industry for taking those materials and being able to turn those into either usable products back within aerospace or within other sectors. So we're keenly investigating and supporting where there are opportunities to do more around that. And then making sure that information is then fed back into the design and development process so that those can be considered up front in the design process as part of an overall consideration of the design, not just designing for cost or for the requirements of the specific aircraft.
Okay, just building on that, I think just taking our perspective on additive materials, it's actually one of the first big contracts we won with the ATI on additive was called TIPOW, which was about recycling of powder. And we've actually discovered something quite interesting through the build processes that we've been working on, particularly in powder bed research. We find ourselves using the powder, probably virgin powder to begin with, but we've realized using the powder multiple times and using it and sifting it and cleaning it takes some processing. And that powder recovery system, we've actually built a patentable solution around which we're now going back to some of the additive manufacturing machine makers. But we're actually looking at ways in which we can recycle the material and to keep the material properties, and we've actually achieved that now. So we're quite concerned about, material cost. When we start looking at some of our biggest components that we want to do additively, we're talking about 1 meter cube powder bed sizes. That's a lot of waste if we don't get that powder recovery working. So what we've been working on is in small scale. We're now going to larger scale build chambers, and we're starting to see then obviously the movement to laser wire deposition is a really big opportunity for reducing the amount of waste that we have in machining. Because if we can build net shape or near net shape using laser wire deposition, that's game changing. We're at the moment in our Swedish business delivering fan case mount rings where previously we were at 20 to 1 buy to fly ratio, we're down to 1.2. So that's a huge improvement on waste. And we continue to look at every opportunity in every site across our 50 machining shops to do the same sort of thing.
And I think maybe from an automation perspective, sometimes automation also gives a bit of an opportunity in terms of energy and packaging and reuse, because a lot of our products, when they enter the facility, they're protected in terms of damage through the logistics processes and through the handling processes. And when you start to think about automation end-to-end from the door all the way through to the assembly, utilising automation systems, the repeatability and taking them away from some of the risk areas of damage, you can also have a think about recyclability and reducing some of the waste you see in an assembly system. So So that's something we're looking at from an assembly perspective. I know that also from an NCC perspective, there's a number of sustainability projects that we're working with some of our research organisations on from a Wing of Tomorrow perspective. So it's certainly a topic for Wing of Tomorrow, and we have a very passionate head of programme on that one as well.
I think on top of the, near net shape manufacturing processes such as powder hipping, wire arc additive manufacturing, I'd also be looking at the wider sustainability picture, and that is how do we make use of materials which use less energy in the conversion, the less energy to manufacture the materials. Look at carbon fibres, for example, to make carbon fibres. You know, the carbonise at sort of 1200 degrees C, etc. So looking at the sort of wider sustainability picture, not just the recyclability, but how do I use less power to actually convert those materials into product? I think that's an important focus area.
Yeah, absolutely. The next question is a bit more around collaboration. So Paul, Brett and Martin, you both mentioned you all mentioned collaboration in your presentations. Next question is, what changes are required in the UK structures supply chain to ensure future competitiveness?
That's with a wide region on that one. I think from my perspective, and we spoke over a break actually on this in terms of from a tooling perspective, and Paul's covered it slightly in one of the preceding questions, is we're seeing with composite assembly there's a real requirement for tooling manufacturers at a complex level, and I think if I've got any of those people in the room, I'd really encourage you, that's the area of development that big OEMs like Airbus, first tiers like GKN and Spirit are reliant on tooling suppliers for complex composite manufacture or composite tooling is going to increase enormously as we move towards the next product. So that's definitely where I'd see the growth area.
I think to be competitive, we have to look outside the walls of the UK. And I spent a bit of time in the Netherlands and in Sweden and the US. I don't think any of those are great benchmarks in terms of productivity, but a lot of money is going into taking out waste in just simple ways. And I think we need to think lean first, but then Industry 4 and the application of technology in digital ways alongside leaning. And when we start looking at that, we've got to benchmark ourselves against some of those in other countries that are doing far better than us, productivity-wise. When you look at the number of robots per head, I think Mark and I have had this conversation before, Korea is something like 10 or 100 times more, I think it's 100 times more than the UK, yeah? And when we think about where we need to apply robotics in our factories, we're finding ways that we could apply cobots and robots in just almost areas we've never thought about before. And possibly we're thinking the wrong way. We need to rethink and reimagine what the future factory will look like. And that's what our GKN Global Technology Centre will be able to do with partners like yourselves in the room. We're really keen to embrace that technology and do the lean factory first, but apply the technology at the same time.
Yeah, absolutely. I think in a report I saw, Laura and I have been discussing, I think the robots per head, we're 22nd in the world behind loads of other countries. So there's a huge opportunity there. Just wary of time, I'll skip to maybe a couple of other questions. This one here is around cost. Do you feel the cost basis of near-net shape manufacturing technologies will rival standard subtractive methods in the near future? So, Brett, I know you've been doing some work in AM.
Yeah, I think we've been sort of concentrating more on the sort of technology development, and I think what we need to start looking at now is the sort of cost engineering environment and what are the true benefits of that. I mean, if we can make things near a net shape, near a nominal size more accurately, that's going to lower assembly costs, for example. So I think it's looking at it in the sort of the overall context rather than just detail manufacturing and looking at it as a detail part, looking at it as from an assembly perspective. If we can get more control within the tolerances of our details, then that doesn't stack up in assembly. That's got to lower those assembly costs. So I think that cost engineering piece needs doing as far as these near net shape processes are concerned for me.
Just building on that, I think one of the challenges that we see, if you try and do like-for-like part replacement using additive manufacturing, the business cases tend to be difficult to prove at the moment with the non-recurring costs of the machines that we're going to be using. You go beyond that and do, I think what Brett's really suggesting is to re-engineer for additive and start looking at the benefits of either functional design or part consolidation, where you get the benefit of moving to, we've got one part that's 7 components today with Airbus, and we can turn it into 1. That takes 7 part numbers out. If we did that across the whole aircraft, that would be a significant saving in the long term. We've got to look at the impact on MRO. We talked about sustainable, beyond just in the first flight. It's 40 years in service, I think you said. I think it was possibly longer. And we need to think about what does that really mean long term in the business case. And I think there are better business cases if we look for across the life cycle and then decide to do that rather than just look for part replacement.
Absolutely. Right, I'll ask one more question, a very quick answer from all of the panel. We're going to skip ahead. It's disappeared. Does the panel think 40% productivity improvement is sufficient to ensure structures work can be retained in the UK?
No, how about 50%? No. Half the cost.
Half the time.
Yeah, indeed.
It's of that magnitude. I mean, we talk half the cost, 40% of the cost. We recognise that if we're going to guarantee the type of volume assembly activity that we have in Broughton today, those are the orders of magnitudes that we need to talk about. And the only way we're going to be able to do that is through designing for manufacture, robotic assembly processes that are flexible, adaptable, that are much faster at changing for customer demand. Because if we don't, the conversation will be about where do you place that type of activity and work for the future.
I think for me, I just take my GKN hat off for the moment and think about broader supply chain and working with the Made Smarter Advisory Board. And one of the biggest challenges, if we as the larger tier ones, working with yourselves, can't find ways to get that productivity gain through the technology, then how are the smaller companies going to get there? I think one of the big things we need to do is to jump in this together and work in a little bit more of a collaborative way. I know there's things that we're not sharing potentially with yourselves that we should be sharing, and that's not right, because actually the bigger beneficiaries are in the room representing smaller companies. We need to try and unlock the intellectual property around Industry 4, otherwise I think we'll just drag ourselves backwards.
I think those are also, it's clear to be saying that those are targets to meet, but we should continue to be more ambitious and strive. We know that the way we make aircraft today is far from as efficient as we could be in the future. So it's about bringing together collective minds to see how far we can take things. And part of that is working with different people and working more collaboratively. So we're actively striving to pull people together from different sectors, from small businesses who bring new ideas to the party, to challenge the way we do things today and bring new ideas into future projects. So actively encourage those who may have ideas on how we can achieve those targets to come to the ATI and those here on the board today to discuss how we can work together to go and deliver them.
And just to put the advert out there again, we have the ATI Boeing Accelerator, which GKN's part of. That's created at least 220 new startup companies that we would never have seen before, that we can jump on. There are 56% of them from the UK, which tells us that there's a heartland of capability we're just not tapping into, that we've made it too difficult for them to access us, and we're now going to meet them this Thursday, not all 220, but 40 of them, and hopefully they'll bring some fruits to bear that we can share with yourselves.
Thank you very much. Well, that's some really interesting insights from all of you. So thank you very much. Draw the session to a close there, wary that the tea and coffees are next on the agenda. So just some of the key themes that were discussed there were around collaboration, automation and digitalisation. So I think there are some key areas of interest for everyone in the room, certainly from our panel members. Alex has given you an overview of the ATI strategy around aerostructures and a roadmap associated with that. So if you've got any questions, ideas, feedback, or sort of good thoughts around it, please do come and chat to us about it. We really want to speak to you more about those items. Other than that, I just want to say a huge thank you to all of our panel. and we'll be around for the rest of the day to answer any more of your questions. Thank you very much.